Okay, we're in section 32 of the notes, and basically what we're doing over here is we're introducing the concept of Riemann sums and the concept of a visual approach to figuring out what the area is. All right, so hopefully, you paid attention during the lecture and you're making sense out of what's being presented to you. But the bottom line is we'll go through examples to reinforce what was presented to you. All right, so we're going to start by going to the whiteboard, and then I'll do one question at a time. This will be a short section. But again, when I say it's a short section, doesn't mean you're not going to spend much time on it. No, you need to study the material to see if you can understand the material. All right, part of that is just studying the material and then reinforcing what you've studied by doing examples on your own. All right, so let me go to the whiteboard. And I'm going to try to share the whiteboard with you. I'm doing that right now. And one problem at a time. All right, so number one, what does it say? It says, the graph of, well, this is a familiar idea to me. I've seen that one many times before. This is the equation of a semicircle. All right, so I'm going to put that down for you, and I'll put it on the side for you. Give me 1 second. And let's take a look at this. So I'm going to write down, we're going to graph out, and I'll review what we've done in the past as well. We're going to graph this out. This is a visual approach to the problem. And, if I were doing that, I would probably square both sides. You get y squared equals 25 minus x squared. What would you have there? X squared plus y squared equals 25. If you're in the class of the principal root, so the y has to be greater than or equal to 0. If you graph this out there, you get a circle. The circle would be a unit, not a unit circle, a circle of radius 5 centered at the origin. Now, what do I know about this? It's not a unit circle. What is it? A semicircle. And we've done this before. All right, so I'm going to get my eraser out, and I'll draw a more accurate picture of it. Just give me 1 second. And erase this business over here. Erase this over here. That's just to review what we've done in the past, by the way. I can draw my picture. My picture is going to look like a semicircle. It looks like this, with the understanding of between -5 and 5. Now I want to write down the integral they have. It's going to be the area from x equals 0 up to 5 of this curve here between the curve and the x-axis. So let's put this over here. I'm going to shade the region they want, which is the one over here. Again, we're not doing a Riemann sum. We're looking at a picture right now. And what's it going to be? It's a quarter of a circle. So write that down for you. It's 1/4 of the area of that circle. What's the area of a circle? Pi r squared. What's r? R is 5. We're going to square it. What do you get over here? 25 quarters of a pi. All right, that's done. Let's go to number two. Number two is, calculate the Riemann sum. And again, we try to provide visual aids for you. Now, someone says, why do you provide a visual aid when I should be doing it myself? You really should do this yourself, by the way. And I want to point out, you should be able to graph this thing over here. What's that guy over there? It's a parabola with x-intercepts of -1. I'm sorry, 0 and -1. So I know it's got x-intercepts at 0 and at -1. And yeah, certainly it's a parabola. And they drew the parabola out for me. It was nice of them. The parabola goes on like this over here. And yeah, you should be able to draw a parabola. Maybe not as good as a machine can do it, but you get an idea, right? Parabola. Now, what they say that the partition, starts at 2 and ends at 5. What does that mean? We're starting at 2. I want to put the point down for you, though. And the point here is going to be 2, comma. And I got to look at the function. What's the function going to be? 4 plus 2 is 6, right? No, I don't think you could have read that from the graph, but certainly that looks like a 2, 6 to me. And the partition ends at 5. And what does that mean? Well, listen to number 5. And what would you get for the y coordinate of that? And it's on the parabola, by the way. It would be 30. Again, looking at the picture seems pretty reasonable to me. So again, I know this is the region they're talking about. All right. So what do they want me to do now? They start talking about the partitions, goes from 2 to 3. So that's this point over here. Okay. I see that. And then it goes to 4.5. And that's this position right over here. Let me write this down for you. This is x equals 3, and this is x equals 4.5. Now, by the way, now they tell me something over here, And these are what's known as the sample points on the interval. The first sample point is 2. And where's that? Right here. We'll talk about how to compute it later. The next sample point is 3.5. Now, where's 3.5? It's right over here. And I'll put these points down later. What's next sample point 5? Well, what I like about this problem over here is I've already got this point over here. It's 2, 6. I've already got this point over here. It's 530. I don't have this point down though, and I want to put it down for you. This point here is going to be 3.5. Well, you know what? I don't like decimals, but that doesn't mean you can't use a decimal. I'm just going to put down the rational number, the fraction. And what's that going to be? 7 over 2. We'll talk about that later. All right. What's 7 over 2? 3.5. Now I got to plug it into the function because I have to find out what that point is. And that's going to be 49 quarters. So it's going to be f of 7 halves. That's going to be 49 quarters plus 7 halves. Well, come there is 4. And what do you get over there? 49 plus 14. Let's see, what's 49 and 14? 63, right? It's not so bad. I'll write that down for you. Again, I'm taking a visual approach to what they want me to do. What they want me to do is draw rectangles in for those given points. And again, I realize the rectangle's already down there for you. And then they want you to get the areas of those rectangles. Now, granted, if this was a large number of points, I don't think I'd be doing this. This reminds me of the last section. We had a large number of points, and I stopped drawing. There's only 3 rectangles there. So let's talk about it. Let's talk about the area that I'm seeing. So my first thing over here, I want to point out, this has a base to it. And what's the length of that base? And again, if you need to blow these pictures up, you can. But the length of that base is going to be, let's see, I'm starting at 1. I'm sorry, I'm starting at 2 and going to 3. That's a length of 1. What's the height of that rectangle? It's 6. That's done. Let's go to the next one. The next one is between 3 and 4.5. Right? So what's the difference between 3 and 4.5? It's 1.5. Now, I don't like decimals, so I'm going to write down 3 halves. What's the height of that? It's 63 quarters. That's not from advertisement. Do I make mistakes all the time? We have a key for it. We'll look at the key later. What's the next one going to be? What's the base of the next rectangle? Well, it starts at 4.5 and it goes to 5. So that's 0.5 or 1/2. And again, I prefer to use the ratio of integers. What's the height of that? Whoops, sorry about that. The height of that is 30. Let me do my arithmetic. Well, nasty, but I can do it. 6 plus, that's going to be 1/8 now, right? What's 3 times 60? 189. Well, 3 times 60 is 3 times 6 is 180. 3 times 3 is 9. What do you go here? 15. I'm going to add together. I'll look at the key later. 15 and 6 is 21. Plus 189, ace. Again, you'd be expected to do grade school arithmetic on exams. Yes, mistakes can happen, by the way. What's 8 times 21? 168. Plus 189. I'll write this down for you. 168, 189. That's 7. Let's see, 15, 357. Ace. All right, let's take a look at our key. We don't have to write a decimal down. I'm going to go for it. 8 into 3, 5, 7. All right, let's see how good they do with the decimal. Now, someone said, I need a calculator. Please use the calculator then. I'm just saying you should be able to do grade school arithmetic. Well, I'm going to say, let's see, 4, right? That gives me 32. I'm using long division I learned in grade school. 37. Let's see, I'm going to say 4. 32. Hope I don't make too many mistakes. 5, 0. Oh boy, let's see what I got there. I'm going to say 5, 6, right? That would be 48. And then I get 20. Well, it's going to get really tough, huh? 2. That's going to be 16 and 40. And it ended. That's my hope in grade school. It ended. So what is going to be 44.625? Let's take a look. Wow, we did all right. All right. Did we use a computer to do that? No, we didn't use a computer. All right. So let me point out, first thing I want you to do is, a visual approach to integration. Right. What do? We looked at the visual. We've been doing this for some time now. And this is that Riemann sum. They give you partitions and they give you sample points, and you got to compute the rectangles for that. All right. Let's go to the next page and see if I can do that. And this one says, they want me to do a visual understanding of this one as well. So I'm gonna put my visual understanding down of this. And my visual understanding of this is, it's primitive, but I know there's an absolute value function here. It looks sort of like this over here. I know I'm starting at -2. Again, I'm not really saying it's a great picture. And it looks like they're stopping at 3. Something like this over here. And so what are they asking you to do is they're asking to get the area of that guy. So I'm going to shade it in. This is my primitive approach to area. I'm looking at it. And that's what that integral represents there. Again, these problems are carefully selected to work beautifully without confusion. Let's write this down. And how do I do that? Well, I'm going to go left to right. They're both triangles, by the way. So the triangle on the left is 1/2. The base of it is 2. Well, you know what? I got to put this height down over here, right? So it's going to be -2. The height of that would be 2. Let me put this one over here. This is going to be 3, and the height of that is 3. So it's 1/2 times the base, which is 2 units. This is 2 units. And what's the height of it? 2 units. Let's go to the next one. 1/2. What's the base of it? It's 3 units. And what's the height of it? It's 3 units. And this is the height of it. These are triangle problems. What do you get over here? 2 plus 9/2. We'll look at the key later. And let's see, what's 2 plus 9/2? Well, I got to get halves. That's 4 plus 9, which is 13/2. Yes, you're supposed to do that arithmetic without a calculator. Bingo, got it. Not bad. All right, so what's next one up? A little more complicated. It says graph it. And if I were graphing this guy, I think I could graph it. And if I were to graph that out, I'm not saying my graphs would look great. We'll look at a better graph later. And the sine function, it looks like this, right? Now, I'm never good at drawing things. I know that. But they want me to start at 3π/2. I'm sorry, -π/2, I'm sorry. Which is over here. And then they want me to stop at 3π/2. Which is over here. Now, certainly this is something we discussed in class, but you may not remember this. And we'll go through it. And what am I noticing about that there's areas here? Now remember this. The areas above the x-axis are positive numbers. And the area below it are negative numbers. Negative areas. Now, what do I notice looking at that picture? And I'm not saying I did a great job of drawing a picture. I noticed this. I noticed this area here would actually fit into this section over here. And this area here would fit into this section. So I'm going to say whatever this number is here, whatever it is, these two over here would cancel it out. So I'm going to say visually, this would be 0. Now I want to go to a better picture. And if you want, you can take this picture, print it. And what you could do if you want, you could actually cut this out with a scissor. You could cut it out with a scissor and you could plop it in over here and it would cover this section of the curve. And you could take a scissor out and cut this section over here and then plop it in up here and it would cover this one. Right, what are we saying? These are negatives and they're canceling, right? This one here cancels this one there because they're identical. What I mean, identical in size. And this one here cancels that one there, identical in size. Okay, here's the problem. I realize the problem. This is, well, if you spend like, days and days and days and days, keep repeating this over and over and over and over again, I'll get it. It's not me repeating it over and over again. You need to repeat this over and over again. What you need to do is study. Now, what are you going to study? The examples that we've given you and the lecture that we've given you. That takes time. So study takes time. How much time? You should be considering a considerable amount of time your academic careers in the study department. And now you might say to yourself, well, if I had a personal assistant that made me do this, then maybe I could study. But without that personal assistant, that's not going to happen. You're not getting a personal assistant. You got to take that initiative on your own. You got to put the study time in. After you do the study time, what you're going to do then is the homework should become easy. And why is that? You did your study. When you do your study, you do this, it's easy. What some students do, they try to do this backwards. No study whatsoever. They try to do an assignment. And typically what they try to do is the most difficult part of the assignment. And then they get frustrated, so they can't do it. Then they say to the teacher, could you do the problem? Yes, the teacher can do the problem, but you're missing out on your educations, the study time. That's where your educations are going to be paying off. Are you putting in the study time? After putting in study times, this stuff should become easy peasy lemon squeezy. Thank you.